Welcome to another video on projections of lines. This video includes very important 10 parameters regarding the projection of lines which are inclined to both planes, that is HP and VP. The main 10 parameters are true length. Here A dash B1 dash and A B2 are the true lengths. Angle of the true length with HP, that is theta. Angle of the true length with the VP, that is phi, which are called the apparent angles. The angle of front view with XY line is called alpha, and front view of top view is called beta. A dash B dash is the front view and AB is the top view. Please note the location of point A, that is A dash and A. These are on a straight line. Location of B, that is projection of B, are B dash and B. These two are also on a straight line. This is the distance between the end projectors. Distance between the end projectors is also noted. Also note that the front view and top view are the two lines drawn in thick lines. All other lines are thin lines. Only these two lines are thick, all other lines are thin lines. Theta and alpha are constructed with the point A dash. Similarly, phi and beta are constructed with the point A. Also note that B1 and B1 dash are on the same locus and B and B2 are on the same locus. The true length is not rotated, but its vertical component. That is, A, B2 is the true length. Its front view or vertical component A, B2 dash is rotated. Here also A dash, B1 dash is the true length. Its top view A, B1 is rotated. Let us see one problem based on the 10 parameters. A line AB 75 mm long. It is inclined 30 degree to HP and 40 degree to VP respectively. End A is 12 mm above HP and 10 mm in front of VP. Draw its projections. It is clear that the line is in the first quadrant. The solution. Draw the XY line first. Then draw one projector. Locate A dash, which is 12 mm above XY line, and A, which is 10 mm below XY line. Locate points A dash and A, and its projectors, its locus are marked as two thin lines. Take an angle 30 degree from A dash and 40 degree from A and mark true length, that is the given 75 mm on both lines, and name these points as B1 dash and B2. So here A dash B1 dash is the true length 75 mm. Similarly, take 40 degree from A and mark this point. B2. Also draw the locus of B1 dash and B2 dash and B2. Draw a horizontal line upwards from B2 to get point 1 on the locus of A, which is the line front view, and we get the point B2 dash on the locus of A dash. Rotate A dash B2 dash to cut the locus of B1 dash at B dash. Join A dash B dash, which is the required front view. Drop a line from B dash downwards to cut the locus of B2 at B, which is the top view of B dash. Join AB, which is the required top view. An alternate method is given here. As in the previous case, we located A dash B1 dash by projecting B2 to B2 dash and drawing an arc. We get B dash. Similarly, drop a line from B1 dash downwards to cut the locus of A at B1. Now draw an arc by taking the distance A as center and A B1 as radius to cut the locus of B2 at B. Join AB, which is the required top view. If all these are correct, we get B dash and B on a straight line. This is the alternate method of drawing the projections. So study these parameters, very important parameters, which is the base for the remaining problems. Here A dash B1 dash is the front view of the line inclined at an angle 30 degree to HP and parallel to VP. So A dash B1 dash is the front view and its top view is A B1. Similarly, A B2 is the top view of the line inclined at an angle 45 degree with with VP and parallel to HP. So A B2 is the top view of the line and its front view is A dash B2 dash. It is rotated to get B1 and this is rotated to get B. So the final required front view is A dash B dash and top view is AB. Another problem. Line AB 75 millimeter long makes 45 degree inclination with VP while its front view makes 55 degree. So its front view is given as 55 degree inclined. End A is 10 millimeter above HP and 15 millimeter in front of VP. That is in the first quadrant. If line is in first quadrant, draw its projections and find its inclination with HP. Solution: draw the XY line first. Now locate A dash and A, that is A dash at a distance of 10 millimeter above XY line and A at a distance of 15 millimeter below XY line. Draw the locus of A dash and A. Now take an angle of 45 degree from A and the true length 75 millimeter. We get B2. Draw the locus of B2. It is also given that the front view makes an angle 55 degree. So angle 55 degree is taken and a line is drawn. Project the point from B2 upwards to get point 1 on the locus of A and B1 dash, B2 dash at the locus of A dash. Now it is rotated, or A dash, B2 dash is rotated with the center as A dash. We get B dash. Join A dash, B dash, which is the required final front view. Now we can draw the locus of B dash also. If it is dropped from B dash to the locus of B2, we get the required top view, final top view as A B2. Front view also can be drawn by drawing the locus of B dash and marking the true length A B2. True length A B2 here, 75 millimeter. We get B1 dash. Measure the angle theta, which is the required angle of inclination with the HP. A dash B1 dash is the angle of inclination. The angle made by the line A dash B1 dash is the angle of inclination with HP. Problem number 3. Front view of line AB is 50 degree inclined to XY line and measures 55 millimeter. So the front view is 55 millimeter long, while its top view is 60 degree inclined to XY line. If end A is 10 millimeter above HP and 15 millimeter in front of VP, draw its projections and its true length, inclination of line with HP and VP, that is theta and phi, are also to be found out. Draw the XY line and one projector. Locate A dash 10 millimeter above XY line and A 15 millimeter below XY line. Draw the locus of these two lines. From A dash, draw the front view 55 millimeter long at an angle 50 degree to XY line. And we get the point B dash. Draw a projector from B dash. And it is also given that top view is making angle 60 degree to XY line. So mark 60 degree from A and locate point B. So we got the front view A dash B dash and top view A B. Then rotating the views as shown, we get the true length. We get the true length. And this true length is taken on a compass and marked here to get B1 dash also. So A dash B1 dash is the inclination, makes the inclination theta with HP, and this is the inclination of the line with VP. So theta and phi are also marked. Fourth problem, a line AB 75 millimeter long. Its front view and top view measure 50 millimeter and 60 millimeter long respectively. End A is 10 millimeter above HP and 15 millimeter in front of VP. Draw projections of line AB if the end AB is in first quadrant. Also find angle with HP and VP. Draw the XY line. Locate A dash and A. A dash is 10 millimeter above XY line and A is 50 millimeter below XY line. Also draw the locus of these lines. Cut a distance of 60 millimeter on the locus of A dash to get the point 2 on it, as it is the line top view. From 2, draw a vertical line upwards, and from A dash, taking true length equal to 75 millimeter in divider or in compass, mark B1 dash on it. Join A dash B1 dash. Now draw the locus of B1 dash also. Similarly, cut 50 millimeter on locus of A and mark point 1 on it. It is the line front view. Similarly, as done above, drop a line from 1 and cut a distance of 75 millimeter from A dash, from A to get the point B1. So this is the true length. Now project 1 upwards to get 1 dash. Rotating the component about point A dash, we get B1 dash. Join A dash B dash, which is the required front view. Similarly, locate the top view or drop a line from B dash to the locus of this line, of this point, get the top view. So AB is the top view of the line. You can measure angle theta and phi as well. The last problem. Top view of a 75 millimeter long line CD measures 50 millimeter. End C is on HP and 50 millimeter in front of VP. End D is 15 millimeter in front of VP and it is above HP. Draw projections of CD and find angles with HP and VP. This is the method. Draw the XY line and one projector. Locate C dash on XY and C a point 50 millimeter below XY line. Draw the locus of these points. Of course, XY line is the locus of C dash. And draw the locus of C. The locus of D and D1 will be 15 millimeter below XY line. So take a distance of 50 millimeter from C and cut the locus of D and D1 to get the point D. Similarly, cut the true length 75 millimeter from C to get the point D1. So we get the inclination of the line with VP from this line. Now from D1, draw a vertical line upward to XY line, that is up to the locus of C dash, and draw an arc as shown here. Draw one projector from D to meet this arc at D dash. We get the front view of the line. That is C dash, D dash is the front view of the line. Draw locus of D dash and cut the true length 75 millimeter on it. Join that point C dash D1 dash, and we get the angles theta and phi. Thank you.